Our last example pulls out all the stops, but the broad strokes again are the same. Our ultimate goal is to try to get a trig function to be isolated all by itself. Now, for example 3, your first thought might be like, hey, I know what I'll do. I'll cancel cotangent off both sides. We actually can't do that. You don't ever really want to divide through by a trig function, because if we don't know what the solutions might be, there might be x values that make it 0, and we might end up dividing by 0. We can't do that. So as tempting as it is to just cross a cotangent off of both sides, that's not what we're going to do. And I'll give you another hint too. Oftentimes, if you're dealing with an equation like this one, when there's multiple trig functions, our first step is going to be actually to get one side of the equation equal to 0, then do some factoring, and then use our properties of 0, like multiplication property of 0, to solve it from there. And that's exactly what's going to happen here. Step 1 is to get one side of this equation equal to 0. I'm going to do that by subtracting 2 cotangent of x off of both sides. And I'll say this, oh man, let's not do that. This whole thing is one term, and this is another, and they are not alike. So I cannot combine them. So the best thing I can do is say the cotangent of x times cosine squared of x minus 2 times the cotangent of x is equal to 0. It looks pretty gross, but it's not a big deal, right? They're not like terms. We can't combine them. Once it equals 0, I've got multiple trig functions. Step 2 is going to be to factor something out, and that's going to become pretty typical. And like I said just moments ago, anytime you have multiple trig functions within an expression, oftentimes we're going to be thinking about factoring. And I can factor a cotangent of x out of both of these bad boys. So cotangent of x, if I factor that out of here, I'll get a cosine squared x minus 2 as my answer. There's my factored form. And what happens is we have something times something else equals 0. So just like when you guys were Algebra 2 students and you had to solve the equation x squared minus x minus 6 equals 0, and you factored it into x minus 3x plus 2 and set each part equal to 0 and solved it, that's exactly what we're going to do here. I need to figure out when the cotangent of x equals 0, and I need to figure out when cosine squared of x minus 2 equals 0. And these both have their own little obnoxious things about them. So there's not much to do on this side with this equation. It's just that I had to remember my cotangent facts, which honestly, if I were you, I probably wouldn't know them necessarily really well by now. But what I hope you do know is that the cotangent is equal to cosine over sine, and this is going to equal 0 whenever this guy equals 0. So this basically is going to boil down to figuring out when cosine is 0. And that's where I might picture my unit circle. I might remember that cosine is related to the x value, and I need to figure out where on here the x value is 0. Did you see the dramatic pause I did? Where's cosine 0 on the unit circle? Here and here. Now I know something else. These are a half a rotation away from each other. So if I want to list all possible solutions, I'm going to go ahead and say pi over 2 plus pi n, and I'm going to cover everything because they're a half rotation away. If you don't like that and you just want to say x equals pi over 2 and 3 pi over 2 or negative pi over 2, however you want to say it, I'm okay with any of those ideas, you know. But I want to say this is definitely a possibility if we're trying to list all solutions. So that's good. Got that part figured out. Now for the second part, I'm just going to need to solve this thing, get that cosine to be by itself, right? So we're thinking like Algebra 2 students again. To get cosine by itself, I got some squaring going on, I got some minus 2 going on. I'm going to start by adding 2 to both sides to give me cosine squared x equals 2. That seems weird. Now I'm going to square root both sides. So the cosine of x is going to equal plus or minus radical 2? Now listen, I'm not like a human calculator, but I know the square root of 2 is definitely more than 1. I don't know, it's like 1 point something something. It's 1.4 something, right? I don't know. But the point is, cosine is never equal to square root of 2. Like, never. Right? Root 2 is like definitely more than 1. And the cosine, the biggest thing cosine could ever be is 1. So this ends up having absolutely no solution at all. Boo. So it turns out that our only answer is what we got from this side of things, which was pi over 2 and 3 pi over 2. That's it. Now, I do need to mention this. If we had started the problem up here by just straight up canceling these things off and working with cosine squared x equals 2, we would have thought this problem had no solution, when in fact, these are solutions to the problem. So at the end of the day, do not ever cross off trig functions, move everything to one side, try to factor and solve from there. There's a short assignment on the classroom page for you guys to try. I'm going to keep it real simple and give it your best shot. Stay calm. Email me questions, and I will look at it. It's due on Friday. I look forward to seeing you guys then. I miss your faces and your initials. See you guys later.